Consider the following video. You, the viewer, are flying across this desert plain, and spot a hot air balloon moving towards you. Having watched that video, along which path do you think the hot air balloon was moving? Please feel free to rewind, and re-watch the video again as necessary. If you answered 3 or 4, you're not alone. Majority of our user study participants agree with your assessment. However, as you might have guessed, these answers are all wrong. The correct answer was actually path 6. As a viewer of this video, when the entire scene is in motion due to camera movement, human ability to reconstruct motion directions deteriorates significantly and cause such perceptual errors to be made. Our work suggests that adjusting the content design of this scene by adding these moving clouds aids in reducing such perceptual errors. For this adjusted scene, do you think your answer to the original question has changed? Please refer to our manuscript for details on what basis these content design optimizations were founded upon. In the rest of this supplementary video, we demonstrate the experimental protocols of our psychophysical and application experiments. Prior to each study, subjects adjust a knob with the help of a visual aid that aims to standardize the field of view of the experimental stimuli to be equal to 50 degrees. At the beginning of trials across the whole experiment, subjects are shown a fixation cross. Upon a button press by the subject, the trial begins and shows them the experimental stimuli. In our pilot study, we run a psychophysical experiment where observers watch the following video clip before answering the direction in which the object moved. In this clip, at first the observer is moving forward with a random heading direction. After 1 second, a small yellow probe appears at the center of the screen. As shown in the top-down view visualization, the yellow ball moves either left or right. Due to the forward self-movement, the probe not only appears to move left, but also toward the observer. In some trials, the direction of on-screen object movement conflicts with the actual movement of the probe. By repeating these experiments across different scene speed, heading, and scene height conditions, we measure the extent of motion judgment errors in human observers. For the application study, we set up a more complex environment representing sports and flight simulation video games. After each video, the subject is asked to choose the direction of object motion that is most similar to their prediction. As was demonstrated in the beginning of this video, along with a baseline control condition video for each scene, we proposed multiple types of adjustments to the scene content that would decrease the motion perception errors according to our model. Now we present samples from different conditions of video clips we used across our studies. Please refer to our manuscript for the analysis of the data collected from our user studies.